surrounded by it.
There's fun in learning around the bend. You can even do it with your best friend. If there's science stuff that you like to know, come watch Allie and CoCo's Science Show.
Hello guys, and welcome to a special school edition of Allie and CoCo's Science Show. Today we are diving into a very important and I think a pretty cool subject that many of you cool kids might be learning about right now. It's the states of matter. Colette, it matters a whole lot because everything is made of matter. There are molecules all around us right now as we speak. No, Colette. Molecules, they're the smallest building block of a substance that still has the same traits of that substance. I know, that's a little confusing, a little much. Think about it like this. One water molecule, H2O, 2 hydrogens, 1 oxygen, one molecule of water will kind of behave the same way a droplet of tons of water molecules. Molecules, atoms, they make up everything. Yeah. And molecules behave differently depending on their state of matter. Not that kind of state, though that's very smart of you, Colette. No, the states of matter. It's how matter around us is represented, and the 3 most common ones are solids, liquids, and gases. Let's start with the solids. This wall's solid. This watermelon's solid. This glass is solid. I'm solid. Dwayne "The Rock" Johnson is definitely solid. Miss CoCo's favorite ball is solid. Wow! These molecules are held tightly together by strong bonds. The molecules may kind of be vibrating, but other than that, there's not a lot of movement. They kind of retain their shape. So there's a little bit of energy between these molecules, but they just kind of do a lot of vibrating and sitting and hanging out. Liquids, like the water from my sink. Oat milk. This nail polish I just used for my spooky September nails. And the blood in my body is liquid. Yay! Liquids are still kind of close together, but unlike solids, they don't really retain a shape together. They kind of take the shape of their container. They flow, they don't hold structure. They're just kind of vibing, guys. There's more energy between the liquid molecules than there are with the same molecules as a solid, because instead of just sitting and vibrating, they're kind of flowing, right? Right. Yeah. Well, the last one? Gas. Ew, ew. Molecules in the gas state are also taking the shape of their container. However, instead of still kind of being connected, they're randomly bouncing around within that container. Right? You see? Yeah. So, yeah, they're moving around with a lot more energy than the liquid, and they're so random. Oh my god, right? So, solids, liquids, and gases, they all have different properties and different energies. Great questions. Those are amazing questions, Ms. CoCo. Gases are all around us, and sometimes they're in us, and sometimes we can see them, sometimes we can smell them, and sometimes we can't. One representation of gas is the air we breathe. Everything in front of us right now is gas, and we have molecules bouncing all around this room. Can you believe it? So oh my gosh, I didn't know this balloon lit up. That's exciting. I'm about to do a very scientific gas exchange. Are you ready, Miss CoCo? So I've just transferred air, gas, from the world around me to my lungs into this balloon. And gas particles, gas molecules, will take the shape of their container. So we know within this balloon, there are air, gas molecules bouncing around all in this balloon. Now the fun thing about the states of matter is you can go from one to the other with energy. I'll show you. Let's do some cooking. Ooh, look at this, Coco. Right now we have the solid form of water, ice, right? Now we're adding energy in the form of heat to break those bonds between the solid water, between the ice. And we're increasing the energy those molecules have so they can go from a solid to a liquid. Now ice, water, has a melting point of 0 degrees Celsius. But some things take more energy to break those bonds and turn it from a solid to a liquid. Like this cast iron takes about 1200 degrees Celsius or about 2000 degrees Fahrenheit to go from this solid pan to a liquid. So you could melt this pan if you had enough energy. Oh, and mercury. Mercury is a liquid at negative 38 degrees Celsius or Fahrenheit. It's about the same. So we're usually seeing it in a liquid form. Oh shoot. I got so into talking about temperature, I wasn't watching the water and it's gone. Where'd the water go? We added so much energy, so much heat to our ice cubes that it melted into water, and the water then evaporated. Where did the water go, right? It went from a liquid to a gas. It became water vapor. Let's make some mac and cheese. As you can see, our water is boiling. We have reached the boiling point of water, which is about 100 degrees Celsius. We are providing a lot of energy for our liquid water to turn it into water vapor. And you can see that there's some steam coming out of our pot. That is our steam. That is our gas form of water. And if you add the lid to the top, you'll see the steam collecting on the lid, and eventually you can kind of see some water droplets forming. This is condensation. It's basically when you're going from a gas state to a liquid state. Now, if we wanted to go back from our liquid, back from water to an ice cube, all we have to do is remove the heat, remove energy, and those bonds will start forming again. The molecules will start slowing down. It's not adding cold energy, we're removing heat, we're removing energy, we're slowing things down. And just like with the melting point, like our cast iron melting at 1200 degrees and water melting at 0 degrees, every substance has its own point where it would turn from a liquid to a solid. Some of those substances take a lot more removing of energy to get to that freezing point. But it's also cool. It's so cool. What did we learn today? We talked about how there are 3 states of matter: solids, liquids, and gases. We talked about how they all require energy to go between those 3 states. And we learned that all molecules have different properties, and some need more or less energy to go between those 3 stages. Matter is so cool. It's everywhere, it's everything. It's this table, this couch, this dog. Everything is made of matter, is made of atoms. Matter truly matters. For a little fun experiment, I want you guys to look around the room you're in right now and list 10 things that are made of matter. And for each of those things, tell me if it's a solid, a liquid, or a gas. Hopefully you can find one of all 3 of those things in your room. I hope so. And for the question of the week, I want to know, what is your favorite state of matter? Do you have one? Mine is liquid. It's always been liquid. I have no idea why, but even as a little kid, I preferred liquids always. So don't forget to hit that subscribe button and ring that notification bell to follow us for more adventures, and we will see you again next time. Bye.